Okay, so good afternoon, all of you. So we are here to talk about OpenTelemetry and how it makes sense in the modern cloud workloads. So we have some agenda today. Uh, this is the agenda for the session today. So I'll be talking about the observability and what is OpenTelemetry, how they are related, then a history of observability. Then I'll talk about the workloads, which is currently in today's world. Then I'll be talking about the OpenTelemetry itself, then the sort of data that is the data that OpenTelemetry is going to collect. Then I'll be talking about the distributed tracing, which is nothing but the combination of the OpenTelemetry signals. Then I will be talking about the components, what is required for distributed tracing. So going forward, this session will be mostly for data collection and how the data is collected and how it is visualized onto a backend of your choice. And I'll be also talking about the dynamic graph architecture, how the microservices are related among themselves. Then, of course, we will have a small demo as well. So without wasting any time, I will start with the basic term, which is observability. So I'm sure you might have heard of this term a couple of times. So to define this in a meaningful manner, I would say this is the ability to understand the state of system which is measuring its outputs. So it's nothing but it is like you have your system running on somewhere else and you want to look into the system and you want to understand the behavior of the system. You want to know the performance of the system. So how you do it? So you have to collect some data which is emitted by the system and you have to just look into it and grab some insights out of it and then try to understand what exactly is happening there. So that is what observability means. That is a capability that observability brings in. And what is required for an observability to happen? That is where OpenTelemetry comes into picture, where this is going to be a mechanism which is going to instrument your system and collect meaningful information from your system and bring it to a backend tool and visualize it there and see what is really happening in your system. So I'm sure these terms are not new. Because these terms definitely existed, eras back, and they are not definitely new. But what is new in this? That is what we are going to see. So let me talk about the history first. So when we talk about modern workloads and when we talk about traditional workloads, what is the main difference? The main difference is the history. The old workloads which were running, they were running together as a single monolith application with a single monolith architecture. They were running on a server, and it was as simple as looking at it with the logs, with the exception stack which they produce during the execution. So it was just like look into your server and see what is happening there. You collect the logs which it produces and you see to it and understand what is happening there. You can look into the stack and you can easily understand what is wrong with the application. So there, the term that we were mostly using was monitoring. So it was just monitoring of the application what you have been running. But now things have changed when we move out for the modern architecture, where we have everything been converted into microservices. So here, these systems or these applications are no longer monolith and they don't run on a single server. So now they are highly decoupled into individual services deployed onto a single or in multiple different geographies or in different servers. And the thing is now the monitoring is going to be very difficult as they don't exist together. Since they are highly decoupled, you have to find a way of how you can get the data from each of these services and how you can collaboratively bring them and make meaningful insights out of it. So as I said, this could be your, if you have a shopping application, and this could be your payment service, and this could be your this could be your shopping cart as is. So once the shopping cart is ready, the shopping cart is going to take care of all your requirements, but once to process the shopping cart, you might need the processing, the payment to be done. So the payment could be a different service. So the shopping cart service will have to talk to the payment service, and it has to get a response from there whether the payment was successful or not. And if the transaction goes well, then only the shopping cart will be able to process the data. So since they don't coexist together, since they are highly decoupled, you will have to get data not only from the shopping cart, but you will also collect the data the from the payment service as well, and bring them together and see if anything went wrong with any of these services. So that's where the term observability comes into picture, where this is going to help you get data from all of these services and stitch them together. So this will be what we'll be going through the rest of the session. So let's start with OpenTelemetry. So OpenTelemetry is nothing. It's a toolkit which is an open toolkit developed by the community to collect data from microservices. So this was initially the project of Open Consens and Open Tracing, and they clubbed together form the OpenTelemetry. So this is a vendor neutral toolkit. That means there is no vendor locking at all. So let's talk about the advantages that OpenTelemetry is bringing onto the table. So as you see, as I mentioned earlier, there is no vendor locking. So the OpenTelemetry is going to be a standard way of data collection. They are going to have a discrete set of protocols. They are going to have a set of formats. They are going to have the set of semantics that needs to be followed. So there won't be any vendor locking, because the data which is coming from any of the microservices and will be in the same format. So you are free to use any sort of tool which follows the OpenTelemetry standards, and you are even free to migrate to any other tools if you are not finding the tool better, because there's the same set of data can be seen without any issues on the other tool as well, because of the vendor data portability. And as I said, they are all common syntax they are following. So there is no confusion, or there is no transformation, or there is no conversion required. And again, you can export the data into any tool or any backend of your choice, because this is a standard way of data collection. Let's talk about the signals, or the set of data that OpenTelemetry is capable of collecting from the microservices. So the very first thing is the metrics. Metrics is nothing but it's a performance data from the system. So this at the runtime, OpenTelemetry is capable of collecting the data from your system, and it is going to graph it or plot it. I mean, the backend tool can collect the data, and it can plot it into a graph, and over the time you can understand, is there any performance or bottlenecks, or is there any other issues into your application.
Okay, I found this on the web, so is there any?
So that is about metrics. And next thing will be the traces. So traces are nothing but this is like when your application is running on your system, your the endpoints which your application is exposing, and when you're getting a request into any of those endpoints, what is happening within the application when a request is made, when a request is hitting the endpoint, what is the underlying span, or what is the underlying activity which is going in through your web service, is what the traces are going to collect. So as I said, you will have multiple web services running on a system, and in your span of time, you will have to know all the data, all the span, how the calls are made, and how much of time it took for all these calls. So everything needs to be captured. And as you see in the figure, the endpoint, the PB1 endpoint HTTP took around 4 milliseconds of time, and most of the time it was went on PB itself, and then it made another HTTP request to PB1, which is another service or another endpoint. Sorry, this is another endpoint, and then it took another milliseconds, and then another it made a database call, and the database activity just took less than 1 millisecond. So overall you are getting the root, you're getting overall 4 milliseconds for this particular endpoint, and you will get a split of how much of time it is spending individually on each of the services or within the call itself. And here you have the logs. So this is the third set of data OpenTelemetry is going to collect from your system. So as you see, it's a timestamped information, and this is the traditional data which we used to get in the monolith architecture as well. And the same set of data OpenTelemetry is also capable of collecting, which is in the form of logs. And this is emitted from the services or the components, and you will be getting it as a timestamp. And the main main advantage of this data is, like, when any request is happening, you will be able to correlate if there is any underlying system activity which has caused any bottleneck or any performance problem, or is there any exception that is happening within the component or services. So all these underlying exceptions or stacks also can be visualized from this timestamp data. So this third set of data. And now let me bring them together and talk about the distributed tracing. So distributed tracing is, as I mentioned, you have your set of services running across the system or across the geographies, and you have to track all of these services and collect the data from all of these services and gain insights from them. So as I mentioned, the HTTP request is basically known as a call. So when a call happens, there can be communications between the two services, and which is basically defined as a call. And the spans are nothing but it is a single action time taken for that particular service. So there can be child spans as well. Like when the initial span happens, we call it the parent span, and all the subsequent scans, if they are waiting, if the parent scan is dependent on the child scan for the response, then there will be child spans. So we'll have to define all this. So this will be defined by the OpenTelemetry when you run your application and when you inject OpenTelemetry into it. So all the spans, including the parent and the child, will be related, and it will be collected data in the correlated fashion. So you will be able to make the data related among the services. And on the right side, as you see, these are the set of attributes which the OpenTelemetry is capable of collecting from. In fact, yes, and you can add custom data as well into it, which is something which we call as baggage. So say, like, if you want to have some additional data needs to be captured during any request call, which OpenTelemetry is not doing right now, then you can add custom data, custom payload as well into your spans. So once the data collection so these are the basic three components which is part of the distributed tracing. So as I said, distributed tracing is collecting of data from this from a distributed environment where you have all the services running across different geographies or on different systems. So the initial step is the generation of the data itself. So first step for you would be to generate the data which is required to be collected. You generate data in all of these services, and collector is nothing but collector is going to collect all this data from these services, and either it is going to process it in the form of either it can encrypt it or it can convert it into any format of its choice, whether it could be a JSON or whether it could be an XML. So all sort of conversions it is capable of doing. Then the third activity for the collector would be to export this data onto a backend tool. So backend is something which OpenTelemetry doesn't provide. So OpenTelemetry provides you only the instrumentation APIs and SDKs, and of course it provides a collector as well. So you can collect the data from using the the signals or the data or the OpenTelemetry, whatever instrumentation you have done in your services, you can collect them using the collector. But if you want to visualize them, then you will need tools like Prometheus or Jigger or Eager like that. So based on the backend of your choice, you can export this data to your backend and you can visualize it. So these are the three components which are associated. Now let's talk about the data generation itself. So how you will generate the span or how you will generate the data within these microservices. So that would be the first step for you when you talk about OpenTelemetry. So basically it supports two ways of instrumentation. One is automatic and the other one is manual. So what do you mean by an automatic instrumentation? So automatic instrumentation is nothing but as a developer, you are writing your application and you are deploying your application, but you are not bothered of collecting any data, or you are not bothered of adding any logs or any other extra information into your services, which OpenTelemetry is going to add. So as a developer, you are not bothered of instrumentation. You just deployed your application. And if you add the OpenTelemetry APIs or the OpenTelemetry ingestion into your application, OpenTelemetry is going to trace your application automatically with zero changes in your code. So definitely, I will show you that in a demo how that is achieved by OpenTelemetry. So as I have shown here, these are just the three steps that you will be doing to inject OpenTelemetry into your application. So you don't make any changes to your application. You will be just creating a new file, and let's assume the index.js is your application, and this new tracing.js is your OpenTelemetry code. So you will just make some imports. You will register a few instrumentations, and you will run it with your application. That's it. You are even the data starts coming in from your application. So we will see this in demo. Now comes the manual instrumentation part. So manual instrumentation is something which is like you will have to need some code changes into your application. So this would be required for those frameworks which are not popular. I mean, let me explain it. Like if you make an HTTP request in your if you're creating an HTTP request or an endpoint which is exposing, those are well-known frameworks, or those are all well-known defined APIs by the Node.js or the Express framework. So OpenTelemetry doesn't have any problem in understanding what sort of call it is and where to place the spans. But if you have written a custom logic within your application, within that endpoint, which OpenTelemetry don't know, like what you're doing within the logic. So the logic where you have your logic within the endpoint, if you want to add some extra information for the traces to capture, then you will need this manual instrumentation in your code. So which is again a pretty simple stuff to add. Likewise, you will have to add dependencies into your project of your application, or your application you have to just import or just add your dependencies. Then you will need a trace provider. So trace provider is nothing but, if you are using a Node.js application, then you will need a Node.js tracer, which is again provided by the OpenTelemetry. So you will just import it into your project, and then you will create an instance of the tracer from that tracer provider, and you will just name your library with that tracer, and this will be your tracer for your application. And using this tracer, you can create spans of your choice. As soon as the call hits, you can start having your span. And not only span, you can add any sort of information, you can add any attributes or any semantics you want to check into. You can add any information into the span itself, and it will be captured. Only thing is, you will need to build your application again when you need to add some manual instrumentation into it. Now, let me talk about the dynamic graph architecture, which will be relevant when I show you the demo. This diagram will help you understand the relations. So as you see, you have your zone, as I was mentioning, you have your zone here, and you have your host, which is nothing but the VM, and which is deployed onto these zones. And within the host, you have your container, an application container running, and within that container, you have your process, and that process is a JVM process, and that JVM process is running a Spring Boot application. And within that, you have another service, which is called APA. And here also, as you see, this is a Node.js application. And if you have a host, you have your container, you have your process here, and process is a JVM, and it is running a Node application. And you have your ES cluster here, and your another app here. So you are just searching for a product and the index is here. So this application is basically communicating with these application. And as you see, they are all executing, or they are all deployed on different hosts, and they are connecting to each other and they are communicating. So as I said, without distributed tracing, you will not be able to understand, or you will not be able to capture meaningful information from visiting in or collecting the logs from APA alone. So you will have to have tracing enabled on all of these services, collect them and correlate them and bring into a backend tool of your choice and then visualize it. So that would be something which this graph explains. So without wasting any more time, let me show you a small demo of the application. So I'll just minimize this. Let me show you the application itself. So as you see, this is a Node.js application, and it has very basic logic. It is exposing an endpoint here, and it has got a MongoDB connection. It is just connecting to the MongoDB server. Then it is inserting some data here, and then if the insertion is successful, you are going to get okay response. In case if the connectivity fails, then you are going to see an error in the console, and the response would be 500. So this is a very simple application, and as you see, this is a plain Node.js application, and you don't see any instrumentation code added into it. But I can still instrument this application without adding a single piece of code here. So what I'm going to do is, like, I have a tracing file, or I have created a new Node.js file, and I'm going to make some imports. So I will just import. I will show you what these imports are. So let me tell you this instrumentation logic. So this is as I said, we have MongoDB. We have MongoDB connectivity. So I am just importing the MongoDB instrumentation, and mine is an Express application. As you said, HTTP GET, I'm using from Express. So I have my Express instrumentation requirement from OpenTelemetry, and of course my tracing requirement is also there, and I have the OpenTelemetry SDK and the OpenTelemetry APIs. All these are imported here, and then the next step would be to create an SDK which is going to do the tracing. And here I have told to add, I'm going to add trace OTLP and metric OTLP. So as I said, we have a trace collection and metrics collection and logs collection. So there are three sort of collections, and I'm going to export them here separately using trace OTLP and metric OTLP. So metric OTLP is defined here. This is the endpoint here, total exporter outline. I will tell you what is this. And then we have this exporter for trace as well. But I have not added for logs. You can add for logs as well. And then you are going to start your SDK, which will initialize your tracing. And then once on exit, it will just shut down. And let me explain few more things here regarding the endpoint. So on the collector part, actually, you can have two ways of data collection mechanism. So let's assume you have a serverless architecture. So you are running your application or your services on a serverless environment. In that case, you won't be able to have a dedicated collector on your environment. In that case, you can directly send it to a backend of your choice directly. If that is one way of doing it, and second way of doing it is like you can directly you can have an agent deployed. So if you have your environment control, you can control your environment, then definitely you can have an agent installed, and the agent is going to expose the OTLP server, a gRPC server it is going to deploy for you, and it will be listening on this port 4317. And you can just define the hotel endpoint here, and whatever data which is traced here will be collected by your collector from this port. So I'm going to have an agent here, and so agent will be for me, agent will deploy a gRPC server for me, and I will just export the data to my agent, and agent is going to connect to the backend, and I can visualize the data. So I have named my service as my tracing service, and yeah, I think pretty much about it. And here, as I said, I am using a tool called Instana for data collection, and Instana has inbuilt collector. So I have defined that here, Instana collector, and this Instana collector will basically connect to the Instana agent, and it will Instana agent will have this port, which is 4317 exposed. A gRPC server will be exposed on this port, and since I am initializing the Instana collector here, all the data which is collected from this application will be taken by the Instana collector, and it will be posted to the Instana agent to this port. So that's how this application is going to work. So let me run this application now. So I'm going to run this. Let me check my MongoDB is running. Yeah, I think I stopped it. So I have started my MongoDB server, and I'm just going to start my application. And it has already started the tracing now. As you will see, the tracing initialized message has already been seen. And now the tracing has started, and you have already started seeing the document insertion because I already have a Postman service which is running here, and it has already started posting few requests onto this endpoint, and it is actually the insertion is successful, and it started inserting the data. Now let me see what I can visualize or what is available for me as from the tracing perspective from my application. So let me go to my backend. So let me show you the agent here. So I have my agent already running, and this is my Instana agent. Instana is a tool which is capable of collecting the data from any environment, whether it could be on-premise or whether it could be a microservice deployed on a different environment. So Instana is capable of collecting the data from any environment of your choice. So I have just started my agent here. I will just show you what the agent needs to, what agent is needed to enable OpenTelemetry. So let me show you this configuration for agent. So this is the agent configuration file. As you see here, I have just enabled my OpenTelemetry collector here. So this is the only change I will have to make when I run my Instana agent on the system. So I have started my Instana agent, and I have enabled OpenTelemetry on the agent. So by default, I'm going to get a gRPC server running and listening on this port, which is 4317, and all the data which is being traced by the OpenTelemetry tracers are going to export into this particular endpoint, and Instana collector will collect everything and it will just post it here. So that's how this application is running. And now let me go to the backend and visualize the data. I think I have it here as well. Yes. So let me show you the agents. So this is the Instana server, which is something which can be of a SaaS environment, and it can be an on-prem. So your Instana server can be deployed on anywhere, and you are going to only thing is like once you have your server installed, you have to deploy the agents. So how to deploy the agents? I will just show you how to run an agent here. Yes, so installing an agent is pretty very easy. Like you can deploy your agent or any of these environments, and the agent is going to collect data from all of these services there. So you have to just click on from where your environment is. So I am just collecting the data from my Mac OS itself. So you have to just download your agent and you have to just run your agent. So it is pretty easy. Now let me show you, since my agent is running on my Mac system, let me show you the agent. So the agent is reporting to the Instana server, and let me go to the server. So let me go to the agent itself, and okay, I think I have a question. Okay, so so I have a question here. So which backend currently supported by OpenTelemetry? So OpenTelemetry is an open source project, as I said, and there is no backend provided by OpenTelemetry. So OpenTelemetry is just a protocol of standards. It has defined the standard of data collection and the format of data collection, and it is in fact giving you a set of APIs and SDKs of all the frameworks like Java, .NET, Go, Node.js. So basically, you will be only instrumenting using the OpenTelemetry, but you won't be able to visualize the data using OpenTelemetry. So, but you will need separate backend tools of anything like Prometheus or Eager of your choice. So backend is there is no currently backend specified by OpenTelemetry, just because OpenTelemetry is giving you a standard set of data. So any backend which can support the OpenTelemetry data format can help you visualize your OpenTelemetry data. I hope I answered your question. Okay, so let me go to the system. So the agent is running now, and I will see to yes. So now my application is running. As you see, the Node.js application is here. It is already running, and I'm just going to click on my application, and all your application metrics, all your application health has already started coming onto the dashboard. And you can in fact see to the performance of it, how the handles and the request and where your HTTP server is running. All this information has already been captured now. Now let me go to the service. So this is my tracing service. As I showed you, this is I have my tracing service defined here, and the data has started coming there. Yes, so now you can see my endpoint. So as you see, this is my endpoint defined, but as I showed you, I have not written any single piece of code into my application, not even for my endpoint. But the tracing code here could go through all of this code. It could do the tracing and it could understand how many endpoints is exposed by this application and what they actually do. So let me get into this endpoint. And as you see, there are no errors as such, and you have already started. As I said, my application is going to give you 200 if the connection is successful and if the insertion is successful. So it has already started showing all the requests here, which is all 200, and there has been no errors as such. And you can also see to how many calls per second, the average of usage of your endpoint. So this is also available as a part of this dashboard. And this dashboard is in fact is not customized. It comes by itself, and you can even customize also just in case if it is required. But now now let me make it live so that you will see the data coming. Okay, now everything is coming and there are no errors. All calls are successful. So now what I'm going to do is I will just stop my MongoDB here. And before that, let me show you one more thing. I'll show you the endpoint. And yes, so this is my tracing service, and now you have your endpoint. And I'm going to stop my MongoDB server. Okay, now I just stopped it. Let's see to the application. Now I think we should start seeing it failing now because the server is stopped. So let's see to the dashboard. We should be able to visualize here what is happening in the system. Let me see to the Postman. Okay, Postman is yet to post. Okay, Postman has started failing. Now I think, okay, now the application has started erroring out. Now I should be able to see the same on the dashboard as well. So let's see what can be visualized here now. Okay, now let's see what has happened for 5 minutes. Let's see. Yes. Now see at 4:07 there has been an error. So as soon as the application failed, now the error has popped up. And now let's see. Now, as I said, it is going to post you 500 and the status code has now changed to red because it is posting 500 now. Now let me go to analyze. So analyze is something that will help you gain insights from your endpoint. So the erroneous call rate has been 100%, so nothing has been successful. And now let's go into this and see what is there happening inside. So as I said, the endpoint is from the tracing service and it has already started failing. And as you see here, the endpoint from there, the middleware query has been made, and from there the express got initialized. And now the request handler call is here. Then from there, actually the MongoDB connection has to happen, for which it is doing a DNS lookup with the MongoDB server location. So as you see here, it has made a couple of DNS lookups before it failed. So it got completely failed here in the DNS lookup. And if you click on any of these failures, you will understand. You can see to the exception what has happened in your application, which is nothing but it's an error saying the connection refused by the MongoDB server. So without any difficulties, you were able to inject the OpenTelemetry code into your application, and you were able to run that. You are able to visualize your application, and you are able to even track the errors which was raising out of your application. So this is how it works. And in fact, you don't need to even look at you don't even need to look at the dashboard here. You can even go to your application, and you can in fact you can add global alerts. So this global alert is nothing but if any erroneous calls happen, as I showed you in HTTP status codes changes, or if there is any erroneous calls, you can just select them and you can just click on what application. If you, on your application of which application you are running, you have to just select those applications and you have to create an event. When you create this alert, then you can what basically will happen is when there is an HTTP status change, or when there is an erroneous call, the system is going to alert you, so that you don't need to look into this all of the time. And here is where you can configure your alert channel, and you can create an alert channel of your choice, and which can like email or Slack or anything of your choice. You can create it and you can run it. So that's how this works. And when I talk about this is one way of doing it, and the another way of extraction would be like you don't need a collector at all, because as I said, in the serverless architecture, you won't be able to deploy an agent because you will not have control of your server. So in that case also, you can directly use Instana. We have tracing, auto tracing, which is in fact supported by OpenTelemetry. So OpenTelemetry has exporters, which instead of exporting to the agent, it can in fact export to the backend directly. So you don't even need an agent in that case. So that's what I wanted to mention before I close. So I think I have covered most of the area here, and I will just stop here for any questions.